Hi everyone, this is going to be the second video on parabolas. Let's start with an equation based on what we've learned so far. You're given that a parabola has an equation 6x plus y squared equals 0. So first of all, I'm going to rewrite this in a nicer way. 6x plus y squared equals 0 gives me y squared equals negative 6x. Now I want to compare it to y squared equals 4px. So 4p is negative 6, so p is negative 3 halves. Which gives me that the focus, now before I go to focus, where is the focus? X-axis or y-axis? Now this is of the form y squared equals negative x, which means it is it upward or downward? So think about it for a minute. Y squared becomes sideways, so this is going to be opening on the left. Which means my focus is p comma 0. So the focus is negative 3 half comma 0, which makes sense. And my directrix is x equals negative p, or x equals negative 3 halves, which is positive 3 half. And there's one last term that we talk about with respect to the parabola, and that is the width of the parabola. Now, of course, in general, the width is infinite because it goes on forever. But there is one point, which is the focus at which we can measure how wide the parabola is. And to do that, we define this term called latus rectum. It's a line through the focus that is perpendicular to the axis of symmetry. That line is called latus rectum. And the length of that is called the focal diameter, or the width of the parabola. Now if I'm over here, this point is p comma 0, so this distance from the y-axis is p. And this is x equals negative p, so this distance is p. So this whole distance is 2p. Right? And by definition, any point on this purple line is equal distance from the blue line, the directrix, and the focus. So this distance is 2p. And similarly, you get that this distance is also 2p. So the width becomes 2p plus 2p, which is 4p. So you see how this 4p sort of figures in our equation, yeah? So it conveys something important, which is the width of the parabola. Now where we use this is, when we try to find equations, we may be given some information in the form of the focal diameter, also the width of the parabola. Find the focus, directrix, and focal diameter of y equals half x squared. So compared to y equals 4px squared, I get 4p is 1/2, so p is 1/8. Now this is y equals, or sorry, this is incorrect. This is 2y equals x squared equals 2y. So comparing it to x squared equals 4py, I get 4p is 2 and I get p is 1/2. Now this is a parabola that goes like that. So my focus is 0 comma p, so that is 0 comma 1/2. My directrix is down here, so it's y equals negative p, or y equals negative half, and the focal diameter is 4 times p, which is 2, just based on this value here. So at the focus, this distance is going to be 2, right at the focus. Now, as I mentioned before, The reason we call this the focus has some physical meaning. Um, if you take a giant reflecting surface, that is shaped as a parabola, then if you shine light onto various parts of this thing, they all reflect and they meet at one point. And no matter where you shine this light from, they always meet at one point. And as you guessed, that point is the focus. And which is why when you have, what are these called? Flashlights. The flashlights reverse this. Meaning, instead of reflecting surface, you get a parabolic transmitting surface and you put the light here. And then when you put the light here, it sort of goes in parallel lines. So in that case, you can see really far because the light travels parallelly and really far. And you place this exactly at the focus of whatever equation represents this parabola here. Last part is we're just going to look at some variety of examples. Graph this function. X squared equals negative 2y compared to x squared equals 4py. You get 4p is negative 12, p is negative 3. Now, generally, this means that is shaped as like that. Yeah. So the vertex is 0, 0 for all parabolas that we learn in this course. Focus is on the y-axis and it's 0, comma, negative 3. Focus. The directrix is up here. Is y equals negative p, so it's y equals 3. And if we want the width is 4p, which is negative 12, but it's a length, so we just say it is 12. So right here, this length is 12. The other kind of problem can be you're given graph and you have to find the equation. So you're given this graph and you're given that the width is 3 halves plus 3 halves, so that is 3. Now what else do you know? Just by looking at it, you know that it is of the form, it's not of the form x squared equals 4py, but y squared equals 4px. But because it's faced on this side, it's negative 4px. But then you know that the width is 4p and 4p is 3. Right? So you just substitute, this is y squared equals negative 3x. So in the graph problems, you may be given the information in a bunch of different ways, but all of them are going to lead to, the ultimate goal is to find the value of p, because that's all you need in order to write the equation. Here's another example. Find the equation of parabola. You're given that if I make a rectangle going through the focus and stopping at exactly the parabola and then going back down, then this area of the shaded region is 8. Okay, so here again we're not given direct definition. Yeah, so but we do know that the width, yeah, this is rectangle, this is perpendicular, and the length of this side is going to be 4p. And we also know that the directrix is somewhere here and it's y equals p, and the distance of this point is p plus p, so this is P. So the rectangle that we are considering has sides 4P and P. So 4P times P is 8, 4P squared is 8, P squared is 2, P is plus or minus root 2. But now we're given that this is actually opening downwards. So it's of the form x squared equals negative 4py. Right? So this should be negative, which means I take the positive value here. So it's negative 4 root 2y. So if I take this equation and I draw the lattice rectum and I form this shaded region, the area is going to be 8. Now one last example. This example, you're not given things in the coordinate system directly, but it says shape of the suspension bridge in a suspension cable in a bridge is parabolic. Find the equation of the parabolic part in purple, placing the origin at the vertex. So that's the actual thing. If I convert this to a more meaningful sort of coordinate system, it says take this purple part. I can't find the purple pen. Let this be origin. Now let's translate these numbers to what we know they are, right? So that right there, 150, that gives me the focus. So that is 0, 150, and this length is 600. And you can verify 4 times 150 is 600. So the 600 meter is the lattice rectum, which means that this point then is the focus for sure. And now it's easy because the general equation for this is x squared equals 4py, and the focus is at 0, 150. So p is 150, and this becomes x squared equals 600y. So we take a real life example and we embed it into a coordinate system. And then we see things like, oh, if this is 600 and 150, that's 4 times, which means this has to be the lattice rectum, which means if the origin is the vertex, the perpendicular line is going to go through 0, 150. So P is going to be 150, which gives me 4P is 600, and the equation is x squared equals 600y. So that's about it for parabola. For the next day video, we are going to talk about ellipse followed by hyperbola.